Okay, my friend, last time we started a chapter called gases. In the chapter gases, my friend, we discussed about the four basic parameters which we use to describe a gas. Those parameters which we describe, those parameters, my friend, are pressure, volume, temperature, and number of moles. These were the four parameters that we discussed in the class. Then after that, we try to formulate few gas laws. Those gas laws, you can formulate any gas law you like. We did only four. And these four gas laws were Boyle's law, Charles' law, Avogadro's law, and there was one more, which was P1 over T1 is equal to P2 over T2. So we discussed four out of four parameters. Out of four parameters, you can have relationship between two parameter and the other two parameter you can keep it constant. In this way you can have the different gas laws. For example, when we talked about Boyle's law, so we said the relationship between P and V. Pressure is high, volume is low. Pressure is low, volume is high, so there is the inverse relationship between the two while keeping temperature and N constant. Then I found the formula P1 V1 equal to P2 V2. 1 stands for initial condition, 2 stands for final condition. When you use P1 V1 is equal to P2 V2, the only thing you want to be sure that on both sides the units are same. Then we talked about the second one called Charles' law. Charles' law is relationship between volume and capital T temperature. Capital T temperature always in Kelvin. So if the temperature is given in degree C, you can add 273.15 to give you the temperature in Kelvin. So V is proportional to T. Greater the temperature, greater the volume, greater the temperature, greater the volume, keeping pressure and N number of moles constant. Then we talked about the third one, Avogadro's law. Avogadro's law is V is proportional to N, V is proportional to N, V is proportional to N, keeping temperature and pressure constant. Keeping pressure and temperature constant, P1 over T1 equal to P2 over T2. Can you please find out the name of this law? P1, T1, P2, T2, keeping volume and number of moles. So if you know the name of this formula, please share it in on the mobile, in your WhatsApp group. Then, my friend, with the help of the first three laws, V is proportional to 1 over P, V is proportional to T, and V is proportional to N. We can write it down in a combined form. V is proportional to NT over P. Or if you remove the proportionality constant, it's going to be V is equal to RNT over P, or V is equal to nRT over P, or I have given you the equation in last lecture that PV equal to nRT. This is known as ideal gas equation. This is known as ideal gas law. Always remember that if you have temperature, if you have R in any of your gas law equations, R, if you have R, then your pressure should be in ATM, your volume should be in dm cube, temperature has to be in Kelvin, and of course, N will be equal to number of moles. Then I gave you two equations, which this one P1 over V1, this is the combined form, or if N1 equal to N2 equal to 1 mole. If it is 1, then I reduce this equation into this form. P1 V1 over T1 is equal to P2 V2 over T2. This is a combined gas equation, combined gas law. In this equation, R is not mojud, R is not there. So if R is not there, as long as you are keeping the units on both sides, and it should be same, the same units, the same unit, then it's okay. Same unit means it should be ATM, ATM, or millimeter mercury, millimeter mercury, or milliliter, milliliter, liter, liter, should be same. Then we talked about the application of PV is equal to nRT. I gave you two equations. One application to find out molar mass of a gas, molar mass of an unknown gas, molar mass of an unknown gas. The second application for PV is equal to nRT is density. Density is equal to P multiplied by mm over RT. These two formula, these two equation are muhim jiddan, 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 jiddan. I solved three questions related to density and molar mass of a gas. Then we discussed about the third law. We know it is known as Avogadro's law. It is known as Avogadro's law. Avogadro's law means if all the reactants and products are in gaseous form or gaseous form. Number two, all reactants and products are at same temperature and pressure. Then instead of using number of moles, I can also use liter. Volume is proportional to N, number of moles. Volume is proportional to N. And then I solve three examples related to this. Again, you will use the chapter 3. In chapter 3, we learned the two relationship. Make sure when you solve the questions related to this, make sure when you solve the questions related to this, make sure your equation is balanced. When you will get the two answer for the same product, then you choose the smaller answer as you have mentioned in limiting reagent. Then my friend, let's go and start with this. This is called calculations involving gaseous reaction. Sometimes they say the word calculation, sometimes they say stoichiometry. Stoichiometry. Stoichiometry is a long word meaning calculation. Stoichiometry, let me write it down for you. Let me write it down. Stoichiometry, stoichiometry, my friend. Stoichiometry, my friend. Let me just check. Stoichiometry. Stoich. Okay, my friend, stoichiometry. Can you see this? This word I have sent you in your group. Stoichiometry. Stoichiometry means calculation. Stoichiometry will calculation. So just 1 minute, my friend. So this is okay, my friend. So this is called stoichiometry, calculations involving. What you will see here, it says this this topic is stoichiometry, very important. In this section, you will have an equation, a given equation. In this equation, you will have a mixture. You will have gas, liquid, AQ, all sorts of things. What we will do, we will have an idea how to do the calculation if I have a gaseous reaction. For example, I will read the question, inshallah it will become a piece of cake, but piece of cake after futur, not now. 2H2O2 going to, this is heating 2H2 plus O2. So this is a balanced equation. H2O2 is a bleaching agent. H2O2 hydrogen peroxide. Hydrogen peroxide, we use it sometime girls, sometime boys. They use it to change the color of their hair, Shara. They change the color, so they want to make brown, green, blue, whatever they want. So this is an equation. Now read the question. This question is very simple, and I want you to understand the question before you solve it. I want 1 liter gas at 20. I want 1 liter oxygen gas at 27 degrees C, 740 millimeter mercury. The question is, how many grams of H2O2 I needed? This is called calculation. My friend, I have 1 liter of oxy. I want 1 liter, or we want 1 liter O2 gas at 27 degrees C, 750 millimeter mercury. What is the question? The question is how many grams of H2O2 I needed so I can heat and I can make this gas. Now, my friend, 1 liter means this is volume. 27 plus 273.15 Kelvin. This will be 300.15 Kelvin. This will be temperature. 740 divided by 760. I will get pressure in atm. I also know R. What is R? Gas constant. What is the value of gas constant? 0.02, 0.0821. 0.0821 liter atm per mole per Kelvin. Which formula I am going to use? PV is equal to RT nRT. Do I know P? Yes. Do I know V? Yes. Do I know R? Yes. Do I know T? Yes. So if I know 4 parameters, my friend, my beautiful people in this world, can I get number of moles of oxygen?
Yes.
Okay, is this the number correct?
Yes, correct.
Excellent. Now, my friend, because you people are so beautiful, if I know number of moles of hair with the relationship with ilaqa, can I get the number of moles of H2O2?
Yes, of course.
Okay, my friend, halwa number 1, mashallah. So my relationship is 1 mole O2, 2 mole H2O2, 0.039 mole O2, 0.078, because I multiply by this. Is this my answer? No. Why? Because I want how many grams of H2O2 needed. So if I know mole, can I get gram?
Of
Yes.
course.
How? I multiply by 34. What is 34? Molar mass of H2O2. Is this mushkil
Molar
exam?
mass.
Is this answer correct? 2.652.
Yes, doctor, correct.
Excellent, my friend. Thank you so much. Now, my friend, is this mushkil example? No. I will do similar example. I will do similar example. I will do similar example and see how it's the same thing. It involves gaseous, balanced gaseous equation, involve calculations. 2C8H18 plus 25O2, 16CO2 plus 18H2O gas. Now, what is the question? This equation is balanced. I have 1 gram C8H18. C8H18, the common name is petrol. Jayyad Mumtaz. I have 1 gram petrol and I want to burn it. I have 1 gram petrol and I want to burn it. I want to burn it. How many liter of hawa, oxygen, how many liter of hawa I need at 27 degrees C, 790 millimeter mercury, and R is always mawjood. Okay, my friend, I want how many, what is the volume of oxygen? What is the volume of oxygen? What is the volume of oxygen? I want volume. Do I have temperature? Yes. Do I have pressure? Yes, but I have to convert into 1.04 atm. How did I convert 790 into 1.04?
Divided by
Divided
760.
by 760. So my friend, I got pressure, I got temperature, I have R, I want volume. Now if I want volume, ayyuhal muslimun, do I have number of moles of oxygen? Do I have number of moles of oxygen? No. So how can I find two unknown quantities? Aha, but I can find number of moles of oxygen. Do you know how? I know 1 gram C8H18. Can I convert into mole?
Yes.
How? Divided by
By
114. What is 114?
molar mass.
114 is molar mass of C8H18. This is my number of moles. Now, my friend, from the relationship, 2 moles, 25 moles, 2 moles, 25 moles. And if I have 8.7 into 10 to the power minus 3 mole, 0.109. Is this number correct?
Yes.
Yes,
Correct. Okay, my friend. Now it will make my life easier. It will make my life simple. PV is equal to nRT. I want to find volume nRT over P. I know N, I know R, I know T, I know ATM 1.04. Is this the correct number? Answer correct.
correct.
Correct. Okay, my friend. I have a very similar example, but I did it later stage. I don't know if, let me find if I can. This is on page 72. Let me check if I can find this example. Let me check if I can find this example. Please write it down. The third example, somebody brought it for me in the class and I did it. This is on page 75. So the third example is on page 75. No, but I cannot do page 75. No, I have to go back. Sorry, my friend, I will go back. 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 I will go. This is finished. I will do the example on 75, but not now. My friend, this is your last section, very small chapter. This is your last section of gases, the chapter called Dalton's law of partial pressure. Dalton's law of partial pressure. Before I start Dalton's law of partial pressure, is there any question regarding calculating between the calculation involving gas equation, the one which we just finished?
No.
Okay. Dalton's law of partial pressure. There are three laws given by the Dalton. Dalton is the name of the scientist. He gave three laws. Law number one, very simple. If I ask you, baby Zahra, baby Fatima, or Nasreen, or Hussein, or Muhammad, what is the pressure in Bahrain today? So what you normally do, now you can use it your telephone and you can find. Suppose the pressure of Hawa, air pressure in Bahrain today is 1 atm. But you know this from your high school that Hawa, air, consists of nitrogen gas, oxygen gas, carbon dioxide gas, and if there is something else, some other pollutant, some other gas. So first law, according to Dalton's first law, he says that the total pressure 1 atm of Hawa or anything else, the total pressure is equal to partial pressure of nitrogen plus partial pressure of O2 oxygen gas plus partial pressure of carbon dioxide plus partial pressure of any other gas which I don't know. So instead of saying N2, O2, CO2, CO, other gases, I am saying A, B, C like this. So what is the first law? The first law says that the total pressure is equal to partial pressure of gas A, partial pressure of gas B, partial pressure of gas C. Qanun number 2. This is number 2. If I ask Brother Muhammad, if I ask anybody, how do we collect gas? Can you collect gas in your pocket? In your pocket of your trouser or soap or something? No, you cannot. You cannot control, you have to connect gas. You have to contain gas either in a gas cylinder or in the lab you collect gas over water. So how do we collect a gas? We collect gas over water. How? This is my reaction flask. I do the reaction. Gas comes out from here through this tube. You have seen in your experiment number 1 where the lime water becomes milky. So that was open, this is closed. So the closed, I have water here in this tube. When the gas will come in, the water level will go down. And whatever I have on the empty space, in the khali empty space, this will be my gas. So I can measure the volume. I can also measure the pressure. But this pressure here, it will have pressure of the gas plus vapor pressure. You know vapor pressure? Pressure of bukhar, vapor of water. So this empty space, it has gas because if it is colored, I can see. But if it is not colored, I cannot see. So this empty space, it has gas and it has some vapor pressure, bukhar from water. So the total pressure, if I measure total pressure, my total pressure is equal to P gas plus P water. This is Dalton's law number 2. This is Dalton's law number 2. I will calculate total pressure. I can find from the handbook or from the table pressure of water at a given temperature. So if you want to find the pressure of pure gas, if you want pressure of pure gas, P total minus this, you will get the pressure of a gas. So what is Dalton's second law? Dalton's second law says P total equal to P gas plus P water. 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 So if I want to find the pressure of a gas, just take the total minus the pressure of water will be given. This total minus this, you will get the pressure of pure gas because you don't want to have a mixture. I am doing this example based on Dalton's law number 2. This example based on Dalton's law number 2. This example is muhim jiddan yani mawjood. This is your equation. Again, I want you to understand the question first. I have 5 grams of a gas, 5 grams, oh sorry, I have 5 grams of KClO3. I have 5 grams 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 KClO3. Just give me a second, please, so then I can get. Okay, this is the patient. Okay. Okay, just a minute. Okay. I have 5 grams KClO3. Now, my friend, I want to know what is the volume. Cancel this, please. Cancel this. Cancel this 2.40 ml. Cancel this, please. Cancel this, please. I have 5 grams KClO3. I want to know what is the volume of oxygen gas. Please write it down. I would like to know what is the volume of O2 gas at this total pressure and temperature is given, which is 27 degrees C. Pressure of pure water is given. Pressure of pure water, vapor pressure is given. Vapor pressure is given. If I know the total pressure, if I know the vapor pressure of water, can I get the pressure of oxygen gas? Yes. Remember what I want. I want find volume of O2 produced. Find volume of O2 produced. I have 5 gram KClO3. This is the molar mass of KClO3. Can I get number of moles of KClO3? Is this the correct number?
Correct.
Correct. Okay, my friend. Then from my balanced equation, 2 mole KClO3, 3 moles O2, 0.0407, I got 0.061 mole O2. Is this correct? 0.067? 061?
Correct.
Correct. I want to use PV is equal to nRT. Whenever I use PV is equal to nRT, make sure that your pressure is in atm, your R is there, your N is number of mole, temperature has to be Kelvin, and when you will calculate volume, it will be in liter also. I want to calculate pressure of pure gas from the Dalton's second law. P gas plus P water. I know total. I know gas water. Can I get P gas? Yes, I can calculate P gas. 810 millimeter mercury. 810 millimeter mercury. 810 millimeter mercury minus 23.76 millimeter mercury. I got 786.24 millimeter mercury. I cannot put this value directly here. Why? Because R is here, so I have to convert from divide by 760 and I will get 1.03 ATM. Is this correct number?
Doctor,
Yes.
from where I got 810?
810. I will go back. I will go back. This is my equation. Did you cancel 2.40?
Yes, doctor.
Okay. So this is the equation at a P total of 810 millimeter mercury at 27 degrees C. Got it?
Yes, yes,
Okay.
doctor. Yes.
Thank you. Now I have the equation PV is equal to nRT. I calculated pressure of pure gas using Dalton's second law. I don't know V, I know R, I know R, I know T. Is this the correct number?
Yes, doctor.
This is correct. But no, not this one, the down, this is the pressure. This is the answer, 1.46.
Yes, doctor.
Correct. Now I can explain this. I can explain the example on page 75. This I will, yeah, this one right here. Yes. Look at this. Please read. I have two sodium metal. I have water, which is liquid, two sodium hydroxide and hydrogen gas. The temperature of hydrogen gas is given, volume is given, R is given, P total is given, P water is given. From P total minus P water, what you will get?
B gas.
P gas. Can I say 1 minus 23.76 or I have to convert this one to 760?
You have to convert.
760. So 760 minus this, you will get some number. This number will be you convert into ATM. You will divide by 760.97. So for hydrogen gas, if I know temperature, do you want to convert into volume into liter or no? No need.
Yes, we need.
Why? Why?
Because
R is there. R is here. I know P, I know R, I know V, I know T. Can I get N number of moles of hydrogen?
Yes.
And if I know number of moles of hydrogen, can I get number of moles of sodium metal?
Yes.
And if I know moles of sodium, can I convert into grams of sodium?
Of course.
Of course. Maybe, okay. So this is, first we have to check, is this number correct? 9.75 10 to the power minus 3 mole. Please check. Is this number correct? All these chapters, especially solution, gases, and chapter 4, Please, 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 you have to be very, very careful.
Yes, doctor, is correct.
Is correct. Then 1 mole hydrogen, 2 mole sodium, 1 mole hydrogen, 2 mole sodium, 9.75 10 to the power minus 3 moles hydrogen. How many moles of sodium I will get? 0.019 moles of sodium, and then I multiply by 23. Why did I multiply by 23?
The molar mass.
Of sodium. Now, my friend, I will go back. So don't forget this. Now I will go to the next one, which is important. So my friend, now this one, this is the one, this is the Dalton's third law. This is the Dalton's third law. This is the Dalton's third law, and the second one I told you Mohim Jiddan 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 Jiddan. Now for Dalton's third law, Mio Khamseen Jiddan and Mio Khamseen Mohim. What is the meaning?
موجود.
Mawjood. Okay. What is the third law? In order to understand the third law, I will go back to my first law. What was the first law I told you? That the total pressure of Hawa in Bahrain today is 1 atm or 760 millimeter mercury. This pressure of Hawa is equal to partial pressure of nitrogen, partial pressure of oxygen gas, partial pressure of CO2 gas, and so on and so forth, depends. So I told you from the Dalton's first law that the total pressure of Hawa in Bahrain at 30 degrees C, because it's too hot today, is 1 atm. But if somebody asks me what is the partial pressure of oxygen gas in this Hawa? If somebody asks me what is the partial pressure of nitrogen gas in this Hawa? Somebody asked me what is the partial pressure of CO2 gas in Hawa. That one I want to tell you. That's why I said Dalton's third law. In Dalton's third law, I will tell you how to calculate individual partial pressure of individual gases. If I tell you the partial pressure of nitrogen, partial pressure of oxygen, and let's say only 3 gases, so I have partial pressure of CO2 gas. So if I tell you all 3, the total answer should be 760 according to Dalton's first law. Sah walala. Yes or no?
Yes.
If I give you the partial pressure of oxygen gas, partial pressure of nitrogen gas, partial pressure of CO2 gas, and if I add them, the 3 answers, the 3 answers should be 760. So this is the basic idea I am going to use. Look at this. Instead of Hawa, I am using. Okay. I have a container, gas container, gas cylinder. In gas cylinder, I have 0.225 mole CO gas, 0.350 mole hydrogen gas, 0.640 helium gas. I have 3 gases. The total pressure of these gases, the total pressure of my cylinder is 2.95 atm. I am interested to know the partial pressure of CO, partial pressure of H2, partial pressure of He separately. In your imtihan, they will not ask for all three. They will ask you for CO or H2 or helium. What is the formula? The formula is very simple. This is the formula. Partial pressure of gas A equal to mole fraction of gas A multiplied by P total. You want to calculate partial pressure of gas B. Partial pressure of gas B is equal to XBP total. For C, partial pressure of C equal to XC multiplied by P total. And what is X mole fraction? Mole fraction. Mole fraction. How do you calculate mole fraction? Na over N total. What do you mean by N total? Na plus Nb plus Nc. No problem. So can I find partial pressure of CO gas? XCO multiplied by P total. XCO, mole fraction of CO gas. What is the individual pressure for CO? 0.225. What is 1.215? How did I get this?
We add them.
Add them together. Multiply by P total, which is given here. Is this the correct number?
Yes, doctor.
Can you check the other two? 3.350 over 1.215 multiplied by 2.95. Similarly, these two numbers are correct or no?
Also correct.
So if I add them together, baby, what will be the number? Partial pressure of A plus partial pressure of B plus partial pressure of gas C
Should
equal
be
to PA, P total. Is this the number very similar to this?
Yes.
It means my Dalton's first law is verified, proved, approved.
Doctor, I get 2.45.
Okay, no problem. Maybe because he has not taken the decimal. If you take the decimal point, maybe you will add more points here. More point here, it will be close. It is 2.45.
Yes, 2.4.
Okay, so then this is ghalat. Okay, check each calculation, my friend. This multiplied by 2.95, 0.46 ATM. Is this correct?
Yes.
I don't trust him because that's why I want to do my own calculation. 0.350 over 1.215 multiplied by 295. Is this number correct? 0.85.
Also yes.
Yes. Do the last one.
I think I know what the mistake he did.
Where is the mistake?
The sum of moles. It is
Aha.
1.315.
Okay, so the number of moles is ghalat. Add 0.225 plus this. Is this the number? 1.215?
I will check.
Please.
Yes, correct.
If this is correct, okay, 0.225 plus 0.350.
The first one, he write 3.325. It should be 225. The first one. The first impression.
But if this is 0.2. This one is 0.225.
And he write 325. The first one.
First one he wrote 225, brother.
I see it. He writes 325. Is this 2 or 3?
Doctor, I get the total correct. 2.95.
Okay, number one, is these three numbers are correct? As Brother Muhammad is saying, is this number correct? 1, 2, 3. This is 1.215. So point.
Yes.
Okay, so it's correct. So 0.225 divided by 1.215 multiplied by 2.95, and the answer is 0.4629. Let's say write it down for 0.463. For example, 0.350 divided by 1.215 multiplied by 2.95, and the answer is 0.8498. 0.8498. 8498. He took it 0.85 is okay. Now this one 0.640 divided by 1.215, 2.95, and the answer is 1.554. This is 1.554. So plus 0.85 plus 0.546, 2.95. Correct, brother? My friend, correct. I got the correct answer. I got 2.9499.
I'm sorry, it's my mistake.
Okay, no problem. Okay, so this is the Dalton's third law. So this is the Dalton third law, and I think I better stop here. Now, my friend, I requested last time, this is the end of chapter 5, gases. Do you have any old exams? Anybody, can you please share it with me? Because I would like to combine some questions, or I would, if you can send me a clean copy, clean copy to my email. Zahra, Fatma, Muhammad, anybody has old exams paper?
Someone have sent old exam, I think, link for old exam in
Can
the
you
group.
please, okay, how many exams did they send you?
I
Because
didn't
I
see.
want it to be on my email so I can upload it. My friend, just 1 minute ago, please, just my friend. Okay, just one.
Doctor,
Yes, my friend. My friend,
doctor, all,
just give me a second, please. Just give me a second, please. Somebody.
okay.
back and let me go back to my. Yes, my friend, you were asking me a question. Somebody was asking. I think Zahra, you were. Who is there, Fatma? Somebody was asking me. Yes, please ask me.
Doctor, all the chapter for final included?
You mean for final exams?
Exactly.
Yes, it is included. Yes. I will tell you, but I will do the revision. I will do the Murajia because they cover chapter 2, 3, 4, 5, then 12, and then the one after this from Monday, inshallah, I will start a new chapter, inshallah. But I would like to focus on few things which is very, very important. Whenever I say Jayyad Mumtaz Jiddan, so it's important. Don't worry about it. I will tell you how to prepare for final exam. When is your final exam? At the end of May, right? 29th or 30th? When is the exam? Final exam. When is the final exam, baby?
31.
31.
31 May. Okay, my friend. 31. No, inshallah, I will do it before, but then I would like to do a revision, a big revision sort of thing. So, so big 31 means it will be 31 means Monday, right? Yes, it'll be Monday. Okay, so no problem. I will do the revision, inshallah. And I want people to come because this is very, very important. Any other question, my friend? So I need.
have a question.
Yes,
about
please go ahead.
Dalton laws.
Okay, my friend.
Should we convert the pressure to millimeter mercury, or we can use ATM?
Okay, which law you are talking about, second or third?
The second and the third.
Okay, for the second one, is the second one, I'll tell you. The third, I will tell you the answer right now. If you want to multiply by ATM, so your answer will be in ATM. If you look at the answers, if the answers are in ATM, then you don't have to convert. But if the answers are in millimeter mercury, that means this has been converted into millimeter mercury. You write down the after conversion here, here, and here. Do you understand what I said, my friend?
Yes, as what we want in the final answer, we convert to it.
Exactly. Now your question related to Dalton's second law. Dalton's second law, for sure you have to convert into ATM, for sure. The reason is that even though the reason is why sure, because look at this. He has given me the total pressure 1 ATM, but I cannot subtract 1 ATM from this number. I have to convert and get the answer and then convert again.
Why we don't convert the millimercury to ATM and?
Oh, you want to convert this into ATM and 1 minus this?
Yes.
Go, sure, no problem.
Okay, we can use it the same way.
The only thing I'm not doing this one into ATM because this is a very small number. So you will have 0.00 something, and then I will tell you 23.76.
But we have a calculator from Japan, Doctor. We can just put the answer and they will give us the answer.
I have 0.03126. Ya Rabbi. 0.0, okay, so minus 1. This will be, oh man, 0.9687. No problem. Go ahead. You won the case. You won the case. But my calculator is also from Japan. That's very nice. Okay. Any other question, my friend? Brother Hussein, Muhammad, please. I want odd answers. Odd exams. Do you have any? But I want to
send you
nice one.
A link in WhatsApp.
Brother, I want to share it with other people so then I can tell which one to focus.
Do you want me to send it in your email?
Please, my friend, please.
Okay.
You always help me, man. Your laptop is also from Japan or no?
No, I think it's from America.
Yeah. MashaAllah. Okay. Any other question, my friend? Any other question, my friend? My friend, what to do with these people? Look at this. Look at this. My friend, I have 30 people total out of 120. Only 30 people came. MashaAllah, MashaAllah, MashaAllah. I think the only time when we get 100% when they have imtihan, sir, because they don't have a choice. Please, okay, Yasmin, Abir, Fatima, Haura, Amina, Naura, Zahra, Sakina, anybody, Hussein, Abdullah. I have, mashallah, 3 Abdullahs. Adil, anybody, any question? Make sure your lab reports are complete. Make sure your lab reports are completed. If it is not complete, please submit in time. Please submit, because they will send me the final sheet of your marks in about a week or 10 days, maybe 2 weeks. So please, I request you to please complete your lab report. Did you submit or did you finish your labs or still not finished?
We finish.
We finished. When did you finish? Last week?
Yes.
Okay, Hussein. So when you finished last week, what did she say? He or she? That when is your? What is the last day to submit your lab reports?
It is today.
Today.
For me. For my
I don't
final
know
lab.
who's your teacher, Hussein.
Wait a minute.
Which section you are in?
26.
26. I don't know that. Maybe Misha or Mavish, something maybe.
I think it's Ali Abdul Hussein.
Ali Abdul Hussein. Okay, yes. He is also just sometimes student. He is very strict. So please make sure that you do your everything, inshallah. Okay, my friend.
Okay.
Okay, great. So inshallah, if you have any question or questions, please, and Hussein also share it with me. This one, the old exams.
I have sent you
Inshallah.
in the email. Have you received it?
No, I didn't check it, my friend. Let me close this one and then I will check it. Okay, Hussein. Thank you so much. Thank you everybody. Let me, brother Muhammad, Hussein, just wait for a minute, please, just to check. Did I stop recording? Because last time they said no, you didn't stop, Madish,